So today we have with us a gentleman from a company called CND Life Sciences. And this is, I guess, by any stretch, a startup company, if I'm not mistaken. But what they've done is they've designed a test by which it can definitively hone in on people with Parkinson's disease. When I say definitively, I think it's a 90 or 95% accuracy, which is really valuable. I think up until this time, there's a couple of standards by which they tested people for Parkinson's, because you can have Parkinsonism. Someone can say you've got Parkinson's, and years later you could find out maybe you don't have Parkinson's, but you do have Parkinsonism. But up until this point, a lot of times they would simply have you look at you, have you do a couple of tests, have you walk up and down, put you on Syn-One to see what your response was, and if you improved, then you had Parkinson's. And then there was the DAT scan, if I'm not mistaken, which was a kind of test, isn't it, Kenny? It's a nuclear med. They inject you with a dye. And then, but what that didn't do is really definitively define anything, but it did rule out certain things. I think that was it. With the CND Life Sciences, it's the test for alpha-synuclein, and it's indigenous to people with Parkinson's from a systemic and physiological perspective. So they can hone in on that protein and with a 95% accuracy tell somebody that you've got Parkinson's disease. So it's quite interesting to say the least, but I'm going to, instead of spoiling his fun, I'm going to go ahead and ask you to join me in welcoming Mr. Kenny Buchanan and his sidekick. This is Laura. She's with Boston Scientific. Thank you.
So thank you for having me. I really appreciate it. And Laura, thank you for all your help and support, Boston Scientific. I'm really happy to be here today. I've been in the startup early stage med tech space now for about 20 years. And, most of that time is spent with operating room technology, and which doesn't really translate to when you're going out to dinner and trying to talk to somebody about your cool technology, because it's not relatable. This new technology is relatable because we can now talk to people, dementia, Parkinson's, everyone knows somebody that's connected to these disorders or these diseases. So just seeing that impact that we have on patients is just really rewarding for me. So as they said, actually just go back one, sorry. The name of the company is CND Life Sciences. We launched the Syn-One Test about 2 years ago. And to date, we have over 300 neurologists offering the test in over 40 states. So one of the things we've understood about diagnosing diseases like Parkinson's disease and Alzheimer's disease is that we never have had a really true test to definitively tell doctors and patients that you truly do have this. And what that means during the patient's lifetime is that we have to rely on clinical features in order to make those diagnoses. And then after somebody passes away, we can do an autopsy. And when we have done autopsy studies in patients with Parkinson's disease, we've seen upwards of a 30% misdiagnosis rate. So 3 out of 10 people could be misdiagnosed. And so really much of the research has been really geared towards trying to solve what we call that diagnostic dilemma in these patients. And so these are our 3 founders. Our 3 founders are practicing neurologists today still. 2 are up in Boston at Harvard, Beth Israel Deaconess Medical Center, Dr. Chris Gibbons and Roy Freeman. And then Dr. Todd Levine is our Chief Medical Officer, and he's in Arizona where our corporate headquarters is and our lab. All 3 of these guys are very well published. So a guy like Dr. Weedy that comes in next week, they all know each other. They all talk and everything like that. So we're backed by science, and that's the purpose of that. So really, our sciences, like I said, is to help clinicians really make that right diagnosis early in state as possible. We call that early diagnosis. And really one of the best ways to do that in medicine is what we call pathology. And that means looking at something under a microscope and trying to assess the changes of what we're looking at. And here at CND, we can do that through a simple skin biopsy. So a simple skin punch biopsy, which is minimally invasive. It's very easy for the doctors to do. It's easy for the patients to tolerate. You don't have to put a stitch in it, and it's very convenient. You can go to an office right now and get it done. It takes 10 minutes. So what we do know about these neurodegenerative diseases is that they all share a hallmark protein with them. And if you look at Alzheimer's disease and Parkinson's disease, the two most common and we look inside the people. Side of your screen there, you see that there's disease with amyloid protein, tau protein. And then in Parkinson's disease, we know that the protein that builds up is alpha-synuclein. And that alpha, what we call phosphorylated, doing what it's supposed to do. And so when we talk about these diseases, we classify them what's called synucleinopathies. And I know that's not a household name. When I first started with the company, I was walking around my house just trying to pronounce it. My wife was just like, stop, please. When we say synucleinopathies, Parkinson's disease being the most common, but we also see this misfolded protein with dementia with Lewy bodies, multiple system atrophy, pure autonomic failure, and REM sleep behavior disorder. So taken as those five, we neuropathies. And so for Parkinson's disease, we've understood that synuclein is at the heart of this disease for a very long time. So James Parkinson first described this disease in 1817, almost 200 years ago. And then almost 100 years, a pathologist named Lewy describes Lewy bodies, these accumulations, like I was saying before, these accumulations of these proteins that are building up. And now the hallmark path of Parkinson. And then in the 1960s, these Lewy bodies, if you will, led to the ability to prescribe L-DOPA as a way to symptomatically treat these patients. And in the 1990s, almost 30 years ago, people realized that the main protein inside these nerves was alpha-synuclein. And so not to get too deep into the science, but this is what alpha-synuclein looks like. Looked at DNCs, is that misfolding has taken place. And so that process of phosphorylated seems to allow that protein to fold incorrectly. And then the misfolding of that protein starts to accumulate and build up, and you have more and more and more bad synuclein. And by the way, we can make this a dialogue too. So if there's something that you want to unpack or ask why I'm doing this, please do raise your hand. And so this is kind of a rough diagram of really what we're talking about here. On the left side, we see that we produce the regular nuclein, and in most people, it folds correctly in a nice origami shape, and then it floats around to do its biological function. But in some cases, that protein goes through that misfolding, like I was saying, and it builds up and accumulates into these piles, and then it leaks out into other cells, and it's absorbed by them, and then it becomes toxic to the good cells. That's basically what's happening. So how do we look at this? We can certainly do a brain biopsy, but that doesn't sound very convenient or safe. So what we do here is we take a skin punch biopsy. And so this is kind of just to illustrate that it's very simple. It's a very small piece of skin. It's much smaller than a piece of a quarter, if you will. So here I'm going to show you a quick video of, it's an animated video of how the procedure is done.
CND Life Sciences is pleased to present this instructional video that will help walk you through the punch biopsy procedure for our Syn-One test and other cutaneous neurodiagnostics. The biopsy procedure is minimally invasive and relatively pain-free. CND provides punch biopsy kits free of charge. You will need to provide gloves, needles, a local anesthetic, and to purchase should be performed by a licensed clinician who should be aware of any precautions before performing the procedure, including if the patient is taking blood thinners or anticoagulants. To start, lay out the contents of the biopsy kit on a clean, flat surface or tray near the patient. Next, label each vial with the patient's name, date of birth, date of biopsy, and biopsy site. To perform the biopsy procedure, the patient should lie flat in a prone position or on their side. It is important to collect tissue from 3 specific biopsy sites. These include posterior cervical, distal thigh, and distal leg. Clean the biopsy site with the alcohol prep pad provided. Use a 30-gauge needle to inject 1 cc of lidocaine, creating a small wheel. Use gentle pressure and rotate the punch biopsy tool until the metal head is fully inserted into the skin. And remember, the tip of the tool is very sharp and should be handled with care. Remove the tool and use forceps to grasp underneath the epidermal layer. Pinching the epidermal layer can cause damage to the nerve fibers. You may need scissors to cut the tissue underneath the dermal layer. Extremely possible. If the biopsy remains in the tool, use the metal probe to gently push it out and into the correctly labeled vial. The biopsy should be submerged and free-floating. Bleeding will occur at the biopsy site, so quickly cover the skin puncture with gauze and the large bandage provided. Repeat the procedure for the remaining sites and place all 3 vials in the biohazard bag included in your kit. Complete the requisition form and collect the required documents. Include with the biohazard bag and place into the return packaging provided. Place the package into the FedEx mailer and affix the prepaid shipping label. Contact FedEx to arrange same-day pickup. You'll receive the test results in about 3 weeks. We're confident you'll find that incorporating the Syn-One test and this simple procedure into your standard of care will provide the objective diagnostic information.
I have a question, Ken.
Sure.
3 samples, 3 different areas. Is there a specific reason for that, or is it just, covering all bases that you're going to get a good sample?
Yeah, yes to all that, but really it's a volume business. We want to be able to see as many nerves as possible. And by taking 3 sites, we're going to be able to get to that, like when you said earlier, that 95% accuracy. So we want to be able to kind of see it from everywhere. We're in the middle of a NIH study right now, a 500 patient study, where they're evaluating where these samples are taking place, and then also looking at what type of nerves we're finding the abnormal protein. And what that study's aim is that now we're going to be able to tell a patient whether or not only do they have a synucleinopathy, but what synucleinopathy. So either multiple system atrophy or REM sleep behavior disorder or dementia with Lewy bodies. Right now, we can say that you have one of those 5. Okay? Did I answer your question?
Yes, thank you.
Yep.
And Kenny, it looks like we.
That's a very good question, and I don't think they know that yet. And we get that question a lot. I can't give you a really good answer, but there's probably going to be some other questions that I can't answer today, but I will provide you with my contact info, and I'd be happy to get you an answer from one of the founders.
And that may be why they haven't found a cure for Parkinson's.
Yeah.
If they haven't figured that out, they're back really at square one.
Yeah. There's a lot of clinical trials that are going on right now that we're involved in, which I'll touch on in a minute, but a lot of these studies, these clinical trials have failed in order to meet that end point, because if you remember the point I made, so if you're